All right, Twitter. Hopefully this goes well. I'm not used to filming these things, so I'm going to be holding my phone with one hand and trying to do everything else with the other. So, simple setup. We're going to show voltage outside the wire, right? So, just a 12-volt car battery. That's going to be hooked into this neon sign transformer, which is going to have these two live wires. Let's see if I can pull it back here. Right, so when I hook it up, we're going to go from DC battery. There's a little transformer circuitry in there. It's going to turn it into 1500 volts at something like 27 kilohertz. So normally if you're running house wiring, 60 hertz, it's a pretty low frequency, and you're not going to really be able to detect this voltage outside the wire because it's a very minimal effect. It's really close to the wire. So what I'm going to show you here is, this is like the way Tesla would work with things. You really like to pump up the frequency in the voltage because the voltage outside the wire becomes more apparent when the frequency is higher, right? It doesn't change the nature of electricity. So even though 60 hertz, you can't really detect it as much, the fact that we're pumping it up to 27 kilohertz, it's still the same nature. Electricity doesn't change. So to make the effect more apparent, we will run it through this neon sign transformer, right? So I'll show you, let me see if I can do this one hand without electrocuting myself. What a pain. All right, we're hooked up. Not a lot going on there, but I will show you. That's 1500 volts, 27 kilohertz frequency. The air is a dielectric, so it's an insulator. 1500 volts. Ooh, I'm setting a fire. 1500 volts. It's got just enough potential to break down the air at very, very small distance. That's how we were able to get that spark gap. Okay, here's the thing. We are going to use this neon lamp filled with neon gas. You can see if we can get that to focusing isn't okay. There we go. Yeah. Anyways, it's really just two separated legs inside there. It's not really connected, and a neon gas. So when we bring this close, but not touching, it lights up. The voltage is outside the wire. There's no current passing through that insulator. We're not touching. It's simply outside the wire. Hold on, I'm going to turn off the light. See if we can make it any more apparent. You can see it's all lit up. All right, so I'll leave this one here. And we'll bring in another one. So you can see, just getting that voltage outside the wire. Then we'll bring in this standard Home Depot CFL light, fluorescent light. Oh, look. Get it close to the wire, and it's lit up. So, yeah, that's it. Simple demonstration. Not sure if Veritasium even bothered to kind of show this. Been a much easier proof than his long video. So, yeah, 60 hertz, you're not gonna notice it. 27 kilohertz, it's pretty apparent. All right, that's it.